query request in Lucene. Now we are focusing on search request. A program that received your search request compares it to the entries in the index and returns result to you. Here you can see run a query from your pish inbox. The steps for this is one, navigate to your pish inbox and to enter your query string in the search bar in the top left corner of the page, and through the press enter key or return key on your keyboard. You can use Lucene to run queries in your pish inbox or on the pish RIP queries page. Here you can see query cache in action. Query cache provide query cache proves useful when you want to enable heavy query performance. Query cache defines an interface that allows caching queries at the junction when it is needed most at the start of the query. The query cache implementation used is LRU query cache. As the name implies, LRU query cache uses the least recently used algorithm to evict keys when the cache is full. Each query creates a wait instance associated with the corresponding index searcher. The default index searcher implementation uses an instance of LRU query cache to cache the incoming query and create the cacheable wait instance. When the scoring starts, the cacheable wait instance check whether the query is present in the cache. If it is present, the cache version is retrieved and returned. Otherwise, a cache load is done and the corresponding instance is returned. Query caches greatly speed up the performance under high load and repetitive queries. However, a large number of distinct query caches actually increase query latencies because of the additional query cache loading times. Also, if the query is being cached is large, that becomes significantly overhead in the entire query latency. The wait represent the pre-index search statistics associated with the query. This is essential because it allows a query to be reused as therefore, the same query can be used to access multiple index searches, but each index searcher will have its own wait instance. Remember that the wait is correlated to index searcher plus query, not just one of the two. When the query is given to an index searcher for execution, the index searcher instance creates a wait instance for the same. The lifetime of the wait is limited to the query execution lifetime within the index searcher. Wait is also responsible for participating in scoring process. Wait creates a corresponding scorer. The scorer scorer is then invoked on various documents that the query is being evaluated against. Note that the wait is completely owned by the index searcher. It is only maintaining statistics for particular query, and the index searcher is free to play with the wait data as much as it wants, with no side effects impacting other parts of the system. Here the class index searcher implements search over a single index reader. Here the LRU class LRU query cache, the query cache that evicts queries using LRU least recently used eviction policy in order to remain under a given maximum size and number of bytes used. Here the index searcher is connected to a cacheable wait via create wait, and then cacheable wait is connected to a index searcher via instance. Then the score supply is given to cacheable wait, and cacheable wait is connected to LRU query cache via get. Then LRU query cache is connected to cacheable wait via object if cached, null otherwise. Then the cacheable wait is connected to is providing a cache object or the default version. Here you can see sample queries. Here the query application and sample query. Here for the term query application single term match. Here the sample query colon bar. Praise query several terms coupled together. All cars with black tires. Here range query ranged of here the in the term query the single term match. Here the praise query the several terms coupled together. The range query range of terms excluding or including the endpoints. Prefix matches given prefix. Fuzzy query Lehmanstein algorithm for closeness matching. Wildcard query regular expression like matching. Boolean query multiple queries connected by logical clauses. As an example, we can consider this code segment. Here you can see the parameter query. The query string to be passed. Here the pass method and in this code here you can see now search the index here. Here pass a simple query that searches for the text here, and in this pass method this passes a query string and returning a query here. Now here we are considering terms in query parser syntax in package org.apache.lucene.query parser.classic. Single term is a single word such as test or hello. A praise is a group of words surrounded by double quotes such as here. Now we are considering fields. If you want to find a document entitled the right way, which contains the text text don't go this way, you can enter this title right way and text go. You can search any field by typing the field name followed by a colon and then term you are looking for. As an example, let's assume the Lucene index contains two fields, title and text is the default field. Title and the text is the default field. If you want to find the document entitled the right way, which contains the text, don't go this way. You can enter this title the right way and text go, or here title the right way and go. Since the text is the default field, the field indicator is not required. Note the field is only valid for the terms that is directly proceed. So the query title the right way will only find the in the title field. It will find right and way in the default field, in this case the text field. Now we are considering term modifiers. The wildcard searches. To perform a single character wildcard search, use question mark symbol. To perform multiple character wildcard, use asterisk symbol. A single character wildcard search looks for the terms that match that the single character replaced. For example, to search for text or test, you can use search here. Multiple character wildcard searches look for 0 or more characters. For example, to search test or tester, you can use the search test asterisk. You can also use the wildcard searches in the middle of a term, t asterisk t. The note, you cannot use asterisk or question mark symbol as the first character of a search. Now we are considering or in Boolean operators. To search search for documents that contains either Jakarta Apache or just Jakarta, use the query here. Or you can use Jakarta Apache or Jakarta. Now we are considering grouping. To search for either Jakarta or Apache and website, use the query here. This eliminates any confusion and make sure make sure that website must exist and either term Jakarta, Apache, Jakarta or Apache may exist. Now we are considering field grouping. To search for a title that contains both the word return and the phrase Pink Panther, use the query here. Now we are considering escaping special characters. To escape this character, use the backward slash before the character. For example, to search for 1 plus 1, open curly brace, 1 plus 1 closing open bracket, 1 plus 1 close bracket and colon 2, use the query here. As an error example, we can consider this one: unable to get the list of search result, unable to process the search request, and invalid search query, and out and repository ID colon TCM, and organizational item ancestor IDs colon TCM, etc. And here you can see apache.lucene.search.boolean query, $, too many clauses, etc. And now this is the end of my presentation. Thank you very much for watching it.